السلام عليكم ورحمة الله وبركاته. ميرونا سرور Chemistry Teacher. Our topic today, Organic Nomenclature by the IUPAC system. Organic compounds divided into two main parts: hydrocarbons, derivatives of hydrocarbons. Hydrocarbons, they are the simplest organic compounds that contains only carbon and hydrogen atoms. Derivatives of hydrocarbons, they are hydrocarbons in which one or more hydrogen atom replaced by other atoms or group of atoms. Hydrocarbons divided into two main parts: aliphatic and aromatic. Aliphatic divided into cyclic and acyclic. Cyclic divided into saturated and unsaturated. Saturated divided into alkenes only. Unsaturated divided into alkenes and alkynes. Cyclic divided into cycloalkane and cycloalkene. Hydrocarbons divided into two main parts: saturated hydrocarbons as alkane. Its general formula CnH2n plus 2. It only contains single covalent bonds. Unsaturated hydrocarbon, the first one, alkene. Its general formula CnH2n. It contains double covalent bond. Number 2, alkynes. Its general formula CnH2n negative 1, triple covalent bond. Alkane nomenclature. Systemic IUPAC naming divided into three main parts: prefix, parent chain, and suffix. Let's start naming alkane nomenclature. Alkanes are hydrocarbons, consists only carbon and hydrogen atoms. Alkanes are saturated because it contains only single bonds. Alkanes general formula is CnH2n plus 2, where n is an integer. Normal alkanes form a straight homogeneous chain. Normal alkanes are named according to the number of carbon atoms present. Step number 1. Find the parent chain, where all carbon atoms lie in a continuous chain, and name it according to the number of carbon as shown. Number 2. Add the suffix "-ane" to the prefix corresponding to the number of carbon atoms in the chain. Find the parent chain that has the longest continuous chain of carbon atom with the most branches. Step number 4. Number the carbon atom of the parent chain from one end to the other in the direction that gives the lowest number to the first branch. In this example, the parent chain is colored by the red color. It has two terminals. This is the first terminal and this is the second terminal. The first branch is nearest to this terminal, so we must start numbering from this terminal, so the correct numbering is 1, 2, 3, 4, 5, 6, not from the other terminal. Step number 5. Name each branch and identify the carbon number of the principal chain at which it occurs. Note the substituent group called alkyl group. An alkyl group is derived from an alkane by removing a hydrogen atom and using the hanging bond left behind as the point of the attachment to the large molecule. The unbranched alkyl group are named by replacing the suffix "-ane" of the parent alkane with the suffix "-yle". Alkyl groups. Step number 5. Name alkyl groups. There is a methyl group's substituent at carbon 2 and an ethyl group substituent at carbon 3. So in this example, this is a methyl group connected with carbon 2, so it will be 2-methyl. This is the ethyl group connected with the carbon number 3, so it will be 3-ethyl. Step number 6. Writing the name of the substituent group. The substituent group are listed first, precedes by its position along the principal chain. Numbers are separated from letter by dash and from other numbers by comma. The substituent group are cited in alphabetical order regardless of their location in the principal chain. Point A. If there are identical substituents, the prefix di, tri, tetra are used to indicate the number. Point B. When there are multiple substituent groups on the principal chain, each substituent receives its own number, even if there are substituents located on the same carbon. Point C. The numerical prefix di, tri, tetra, as well as the prefix cis and trans, are ignored in alphabetizing. The prefix iso, new, and cyclo are considered when alphabetizing substituent group. Step number 7. The name of the alkane corresponding to the principal chain is given after all of the substituent group are listed. In our example, the net name is 3-ethyl 2-methyl pentane. Step number 8. When the numbering of different group is not resolved by any of the other rules, the first cited groups receives the lowest number. Step number 9. Since ethyl is cited before methyl alphabetically, the principal chain is numbered to give the ethyl group the lowest number. In our example, the letter E is precede the letter M in alphabetically, so the ethyl group must take the smallest number from the terminal, so we must number this chain from this terminal to give ethyl group the smallest number. Step number 10. Complex substituent with branching, named by applying the 4 previous rules with some modification. Number the complex substituent separately from the parent, beginning numbering at the point of attachment to the parent chain. Complex substituents are set off by brackets. This is an example. 2,6 dimethyl 1,4 brackets 1-methyl propyl decane. As example, if you apply the IUPAC nomenclature rule to the 5 isomers having a chemical formula C6H14, hexane, 2,2-dimethyl butane, 2,3-dimethyl butane, 2-methyl butane, 3-methyl butane. Alkene nomenclature. Alkenes. They are hydrocarbons which have carbon-carbon double bond, functional group, and are unsaturated hydrocarbons with the molecular formula is CnH2n, which is also the same molecular formula as the cycloalkane. Step number 1. Alkenes are named using the same general naming rules for alkanes, except that the suffix now is "-ene". If there is more than one double bond, modify the suffix to indicate the number of double bonds. For example, 2 equal adiene, 3 equal atriene, and so on. Step number 2. The parent chain is the longest chain containing both carbon atom of the double bond. If the alkene contains only one terminal double bond at one end of the molecule, then it is not necessary to place any number in front of the name. Butane, C4H10. There is only one double bond at this terminal, so we haven't to place any number in front of the name. In this case, the double bond is at the carbon number 2, so the name will be bent 2ene. If the double bond is not terminal, then the carbon should be numbered to give the first of the two double bond carbons the lowest possible number, and that number should precede the ene suffix with a dash as shown in below. Bent 2ene. Step number 3. If there is more than one double bond in an alkene, all of the bonds should be numbered in the name of the molecule, even terminal double bonds. The numbers should go from lowest to highest and be separated from one another by a comma. The IUPAC numerical prefix are used to indicate the number of double bonds. The first molecule has two double bonds in position 2 and in position 4, so the name will be octa 2,4-diene. The second molecule has two double bonds in first position and 5 position, so the name will be deca 1,5-diene. Step number 4. Double bonds can exist as geometrical isomers, and these isomers are designated by using either the cis and the trans designation. The cis isomers have the two largest groups on the same side of the double bond, and the trans isomers have the two largest groups on opposite side of the double bonds. This is cis, this is trans. Alkyne nomenclature. Alkynes are organic molecules made of the functional group carbon-carbon triple bonds. Alkynes have the empirical formula of CnH2n-2. Alkynes are unsaturated hydrocarbons. Alkynes have the ending -ene. Step number 1. Alkynes are named using the same general naming rules for alkanes, except that the suffix is now -ene. Step number 2. Find the longest carbon chain that include both carbons of the triple bond. Step number 3. Number the longest chain starting at the end close to the triple bond. Step number 4. Label each of the substituent at its corresponding carbon. Arrange the substituent in alphabetical order. Step number 5. When there are two triple bonds in the molecule, find the longest carbon chain, including both the triple bonds. Number the longest chain starting at the end closest to the triple bonds that appear first. The suffix that would be used to name this molecule would be diene, for example, 4-methyl 1,5-octadiene. Step 5. Substituent containing a triple bond are called alkynyl, for example, 1-chloro 1-ethynyl 4-bromocyclohexane. A molecule that contains both double and triple bond is called an alkynene. The chain can be numbered starting with the end closest to the functional group that appears first, for example, 6-ethyl 3-methyl 1,4-monoenine. Reference. Thank you and goodbye.